Okay, guys, I figured I would go over question number 2 on the pH of buffers worksheet. So to do this problem, one of the first things you'll need to do is convert the Ka to pKa. And to do that, you'll simply just take the negative logarithm of the Ka. So that's how I obtain this 9.25 number. The next thing that would be very helpful is to look at the two chemicals that are creating this buffer. So we have ammonium chloride, which is NH4Cl, and we have ammonia, which is NH3. Now, since this NH4Cl has one more H than the NH3, it's going to be classified as the acid in the buffer, and the NH3 is going to be the conjugate base. So what's going to happen is they tell us that they're going to add 0.0248 moles of acid to this buffer. So what's going to happen is the conjugate base is going to have to react with the acid to neutralize it to help prevent any major pH changes. So basically, if an acid is added, you need to react it with the conjugate base. If they happen to add a base, you need to react it with the acid. So in this case, I'd have the following chemical reaction. Now, I have two numbers here, this one and this one. You might be wondering where in the world they came from because they're not given in the problem. These two numbers were actually calculated. So I used the molarity and the volume of the two chemicals that make up the buffer to calculate the number of moles of the acid, which would be here, and the number of moles of the conjugate base. Now the moles of the HCl is just given to me in the problem. So what's going to happen is I'm going to subtract the moles of the acid that's added from the conjugate base. You can see here that will change its number to this equilibrium value, and then HCl will go down to 0. When I do this, the H plus from the HCl is going to bond with the NH3, and we're actually going to end up transforming this into NH4Cl. So you'll notice I added the same number of moles I subtracted over here to get a new value for the NH4Cl. Now once you have these two equilibrium values, it's pretty simple because this is your A minus value and this is your HA value. So you'll just plug it into this formula. As long as you know the identity of A minus and HA, you're golden. So here you can see I took the pH, set it equal to 9.25 plus the logarithm of A minus over HA, and these are the new values I calculated, and that will tell me what the pH will be. Now, I'm not going to actually calculate this for you guys. I'm going to have you guys put in a little bit of work and find this pH, but this should be pretty helpful.